This is Schweitzer. Quick little introduction to today's topics. Yesterday we watched a video on the combined gas law. This shows the relationship between the various properties or variables that can affect gases, which are going to be pressure, temperature, volume, and then the only one it doesn't include is N, which is the number of particles. So if you have, let's say, a balloon, which might look like this, then that balloon is subject to pressure, either pressure from the outside or pressure from the inside. Temperature, of course, temperature is measuring how fast the particles move. And then the volume, of course, is going to be subjected by all the other properties as well. I could potentially have a rigid container, which then would have a constant volume, so the volume wouldn't change. But the temperature and pressure could change. Keep in mind, pressure is dictated by particles colliding with the walls of the container. Whether it's a balloon or whether it's a rigid container, then this pressure is simply indicated by the number of collisions per area of the container. Same number of particles in a smaller area, then we have more collisions and therefore more pressure. So again, if you have a smaller volume, then you're going to have a greater amount of pressure because you have same number of particles, same number of collisions with smaller area. If you were to increase your temperature, now temperature increases speed of the particles. So obviously, if you increase your speed, you can have more collisions. Therefore, you increase your pressure. So there's a few relationships here. If by chance if you increase your speed, your temperature, you can also increase your volume if those collisions help expand your container. So there's a number of different ideas that we want to sort of try to understand properties of gases. But either way, as far as the mathematics are concerned, it's quite simple. We have P1V1 over T1 equals P2V2 over T2. We have 6 variables here. A few things you might want to note. Temperature has to be in Kelvin, which is the Celsius plus 273 equals Kelvin. Other than that, make sure your units are consistent. So use the same units. So if you want to use ATMs for pressure, that's fine. Or you can convert over to 760, 1 ATM equals 760 torr, or millimeters of mercury, which is fine. But be consistent across volume, any volume you like. Be consistent. Keep in mind, for solving for a variable, things can move diagonally across the sides. And you can solve for whatever variable you like. Sometimes they may not give a variable. If they say it's a rigid container, then let's say volume will be the same on both sides. You can either just take it out entirely, or you can substitute a value in. It could be 1. If it's 1 on both sides, it cancels. Other than that, make sure you don't trap x in the bottom. You never want to solve x on the bottom. You want to move it to the top. But that should be all set. For general chemistry, so for general, you'll get about, let's say, 20 minutes to work on combined gas law A. Combined gas A. And then Mr. Van will ask and answer any questions. You can wander around, make sure you get some questions answered. Then he's going to show you the answer video. All right, take a look at him at that point. If you are if you're in honors, okay, you should be ready to roll on this. Honors. Then Mr. Vance is going to show the answers immediately. Okay, and then you also show the video on the next PV equals nRT. Both of you, assignment-wise, combined gas B version. That's due on Wednesday, both of you. No excuses. If you have any questions, get them answered. I will be at school 7 o'clock in the morning. If you have any questions, thank you very much.